Good afternoon, students. Today we are going to learn about neutralization curves. So last class what we all discussed, it's about neutralization titration and theories, different theories like Brown-Set theory, Lex-Fleck concept, etc. And also very important acid-base indicators theory, that is Ostwald theory and resonance theory. So it's very important. Now let's discuss this. So neutralization curves. So what do you mean by neutralization curves? So neutralization curves means it's a curve that is pH will be on the y-axis and amount of alkali will be on the x-axis. Such type of curves we can call it as neutralization curves. And there are five categories for the neutralization curves. And the first one is strong acid versus strong base. So here the strong acid is hydrochloric acid and the strong base is sodium hydroxide. So when we are adding strong base, that is NaOH2 HCl, that is a strong acid, the pH will start to change. So during the beginning of the titration, the HCl will be more, acid will be in excess. Then after the color change, the base will be in excess, that is NaOH. So here the salt produces final result will be neutral. The solution will attain its end point at pH 7. So usually the indicator color change during the vertical position of this type of curve. So we are using phenolphthalein, methyl orange, etc. as indicators. See, this is the graph. So this is pH here and here volume of alkali. So this is the equivalence point. At this point the color change means the titration is complete during this point. At this region the acid will be excess and here the base will be excess. So it will reach up to 13, you can see here. Next, weak acid with strong base. So here we are using weak acid is acetic acid and strong base is NaOH. So here the pH will be from 3 to 5 because it is weak acid. And the salt produces final result is basic salt. And the equivalence point will be greater than 7. Last graph it was 7. Then here we are using suitable indicators for phenolphthalein. You can see pH will be 3 to 5 and we reaches the equivalence point greater than 7 and the salt produced is basic. So the graph will be like this. Next, strong acid with weak base. So here strong acid is hydrochloric acid and the weak base is ammonia. So at the beginning of the titration, we all know that concentration of hydrochloric acid will be more. So the pH will change from 1. Finally, the salt produced is acidic. But equivalence point will less than 7. You can see the graph. See the pH will start from changes from 1 and we reaches the equivalence point here. This less than 7. Next one, weak base with weak acid, that is acetic acid versus ammonia. So here the initial pH will be 9 to 11 because it is weak base. So there are only very small change in pH. That means equivalence point will reach very soon. So usually we don't use these type of titrations because it's very difficult. So graph will be like this. So initial pH will be here. So it reaches the equivalence point at pH 7. Next one, very weak acid and strong base. So here very weak acid is boric acid and the strong base is NaOH. Actually, we cannot directly titrate this. First of all, in the presence of NaOH, that is, we are treating it with polyhydric alcohol such as glycerol, mannitol, etc. So we'll get glycerine boric acid. So that is very strong acid. Then we are titrating with again standard NaOH using a suitable indicator, that is methyl orange. So very weak acid means it is boric acid and strong base is NaOH. So boric acid is a weak acid. So first of all, it is treating with polyhydric alcohol such as glycerol mannitol and titrating it with standard NaOH. So we'll get glycerin boric acid. That is very strong acid. Then again we are titrating it with standard NaOH using methyl orange. Then choice of indicators or else selection of indicators. That is for strong acid base titrations. We can use any indicators at the range 4.5 to 9.5. But for these type of solutions, 0.01 normal solutions, where pH will be slightly smaller, that is 5.5 to 8.5. Then in the case of weak acid and strong base titrations, so the pH will be on alkaline side. It is due to the hydrolysis of the salt. So we should select the indicators on the alkaline side like phenolphthalein, thymol phenolphthalein, thymol blue, etc. Then for strong acid and weak base titrations, so equivalence point will be on the acidic side. So we have to select the indicators on the acidic side. So that is methyl red, methyl orange, methyl yellow, bromocresol green, bromophenol blue, etc. we select. Then for strong acid and weak base titrations, see there is no sharp rise in these type of curves. So we should not use simple indicators like phenolphthalein, methyl orange, etc. So in such cases, we prefer mixed indicators. For example, we are mixing neutral red and methylene blue for the titration of ammonia and acetic acid. So used to mix the indicators. Such type of indicators we can call it as mixed indicators. So it will give us a endpoint within a limited pH. Okay, so that's for today. Thank you.